We know the kinematic equations that we derived last time. V minus V0 is equal to AT. X minus X0 is equal to V0t plus 1/2 AT squared. And V squared minus V0 squared is equal to 2A X minus X0. We will adapt these equations for the free fall motion. The free fall motion is a vertical motion in which the acceleration of the object is the acceleration of gravity, g, which is 9.8 meters per second squared. Sometimes we can round it to 10 meters per second squared. So let's see how we modify these equations to describe this type of motion. First, all the x's will become y's. This is just a cosmetic notation, but because the motion occurs vertically, traditionally we label the vertical axis as y. And in fact, in this case, there is no need for the x-axis. The motion happens vertically, that means the y-axis will be enough. And the second change to those equations is to take into account the fact that acceleration is g. However, the acceleration of gravity always points down. We haven't learned that yet. We'll learn that later in this course. The acceleration of gravity always points down. On the other hand, the y-axis always points up. Therefore, the acceleration of gravity, using the vector notation that we learned earlier this semester, will be gj with a j hat with a negative sign in front. Recall that for the y-axis we have vector j hat pointing in the positive y direction, while on the other hand the acceleration of gravity points down. So because of that, the correct vector notation of the acceleration of gravity is negative g j hat. However, we are not going to use this notation at all. All we will do will be to use a negative value for the acceleration in these equations. So our kinematic equations become v minus v0 is equal to negative gt. I replaced a by negative g. Y minus y0 is equal to v0t minus 1/2 gt squared. And v squared minus v0 squared is equal to 2g with a negative sign in front, y minus y0. So these are exactly our old kinematic equations with two changes. All the x's have become y, and all the a's have become negative g. And this is it. How do you use this in a problem? Let's see. So let's pretend there is a stone thrown upward from a window at a height of 20 meters. The speed of the, let's say, is 10 meters per second. What is the speed of the stone when it hits the ground? the speed when it hits the ground. We have to draw, and all we have to draw is the y-axis. Let's label all the important positions in the problem. 0 will be the ground. 20 is the initial position of the stone at a height of 20 meters. What is the speed when it hits the ground? The time is not involved in this problem. Therefore, we will use the third equation. So let's write the equation the way we had it on the previous page and see how we can adapt it, how we can apply it to our problem. V is the final velocity on the ground. So this is the unknown. This is the unknown. V0 is the initial velocity, and it is 10 meters per second because the stone was thrown upward. If the stone were thrown downward, this would have been negative 10. The initial position, y0, is 20 meters. And the final position is 0 meters because the final position of the stone is on the ground. So our equation becomes v squared minus 10 squared is equal to negative 2 times 10, I'm using g equal to 10 meters per second squared for simplicity, times the final position, which is 0, minus the initial position, which is 20. So the equation becomes v squared minus 100 is equal to minus 20 times minus 20, which obviously becomes 400. V squared is equal to 500, and V is 10 square root of 5 is going to be 22.3 meters per second. However, we have to be careful. In principle, this is correct, and this is the answer. This is the speed. How about the velocity? Well, obviously when it hits the ground, the object is moving downwards, so the velocity must be negative. Is there a conflict here? We obtained a value of 22.3, positive. Well, it should have been negative. No, there is no conflict, because technically the solution of v squared is equal to 500. We have two solutions. We have a solution positive 22.3, and we have a solution that is negative 22.3. And in this problem, we should have selected this. So if the question is what is the speed, the answer will be 22.3 meters per second. If the question is what is the velocity, we'll say negative 22.3 j